Page 214 from SciPAD, Conservation of Momentum, a core component of the Level 2 Mechanics standard. Most years you'll have a question around something on these next couple of pages. The principles of conservation of momentum states that the total momentum before a collision or explosion is equal. Now that's the big idea there to the total momentum after. Okay, and so we're looking at this idea of total momentum, and so we could essentially just say that is Pi, or the total of Pi, the total of the momentum before, is equal to the total of the momentum after, and the condition for that is an external force is not considered, so there's no external forces. Some years you can get up to an excellence, or that's an achieved question, state your assumptions, no external forces. So we're often looking at something like this, two trolleys, and we're going to do some virtual experiments around this soon. If two trolleys collide, they should rebound away so that the sum of their initial momentum is equal to the sum of their final. However, if two trolleys collide and the frictional forces are large, the total momentum will not be conserved. It's important to realize that this does not mean that the principle of conservation of momentum has been broken, it's just that friction is an external force. So we have to always make this assumption that there are no external forces in order for the condition of Pi equaling Pf, and it's the sum of Pi equals Pf. So if we do question number 1, that'll all make a bit of sense. So Dave is driving a bumper boat, and he collides with another bumper boat driven by Angela, and so you could go M Dave and M Angela if you'd like to. Before the collision, Dave is traveling, so you could go V Dave is traveling at 6 to the right, while Angela is traveling at V Angela at 4 to the left. And now they're going left and right, and so our typical convention is to have a plus and minus. And so if we drew a set of axes, you typically have this being the plus quadrant and this being the negative quadrant. And so if this is on the right, I'm going to call this one plus 6, and I'm going to call this one minus 4. Now calculate the total momentum of Dave and Angela's bumper boat. So we're going to say P initial is going to be M Dave V Dave plus mass of Angela, velocity of Angela. And so Dave is 250, and he's got a velocity of 6, and Angela has got a mass of 220 and a velocity of minus 4. The reason one's positive and one's negative is because of the direction, and because momentum is a vector, and the direction of the vector is always the same as the direction of the velocity for momentum. And so with that I get 620 kgms minus 1, and this here is a positive number, so that means it is in the rightward direction. After the collision, so now we're looking at the final. Dave is traveling at 2 meters per second to the right, so Vf Dave is going to be 2, and it's going to be a positive number because it's to the right. So find Angela's final velocity, and so it's going to be the same equation as this Pi right up here. So Pf is going to be mass Dave velocity Dave plus mass Angela velocity of Angela, and we know, or we're making the assumption that there's no external forces, and so we're going to say that the final momentum is going to be the same. We're going to assume that Dave's mass hasn't changed, so 250, and we know that his velocity is now 2, and the mass of Angela we're going to assume hasn't changed at 220, and now we're looking at the velocity of Angela final. And so what this ends up doing is saying 620 minus 500, 250 times 2, is going to be 120 equals 220 velocity of Angela. And so 120 divided by 220 gives me a velocity of Angela of 0.54 meters per second. Now that is a positive number, and so that is to the right. C, state the principle that you've used, that Pi equals Pf. They probably want that in a fancier way, and so you could just say the conservation of momentum. Question number 2. Two stationary trolleys are placed together, and the right hand trolley has a mass of 2 kilograms, and the left hand trolley has a mass of 1 kg, and a spring fires the two trolleys apart. The total initial momentum of the two trolleys So it does say 2 stationary trolleys. And so we could go through all that calculation. Pi equals m1 v1. So if I call this one number 1, and I call this one number 2, this is still number 1, this is still number 2, then m2 v2, and this is mass of 1 but a speed of 0, plus a mass of 2 times a speed of 0, anything times 0 is 0, kg ms minus 1. So you probably could have automatically figured that out just by reading the question. The right hand trolley has a velocity of 2 meters per second. Sorry, let's try that again. The right hand trolley has a velocity of 2 meters per second to the right after the explosion, and calculate what that velocity is. So we know that they're stationary beforehand, and so the total momentum still must be 0, and if that's got momentum to the right, then this one must also have momentum, but it must be in the opposite direction because of momentum being a vector. So Pf equals 0, which equals m1 v1 plus m2 v2. So I'm writing m1 v1 because that's momentum, and this is momentum, and I'm adding them together, so this is the total momentum afterwards. The mass of cart 1 is 1 kilogram, and the velocity is what I don't know. The mass of cart 2 is 2 kilograms, and the velocity of that is also 2. And so I get 0 equals v1 plus 4. And so what does that give me? It says that v1 equals minus 4 meters per second, which is good. That means that it has a velocity to the left of 4 meters per second. Boom. That's that question done.